So in this video, we're going to basically review the geometry concepts for trigonometry that you learned. I know it's been a couple of years, so we like to review it. Here's the trigonometry term and where the word comes from. We're measuring a triangle, and in this case, it's always right triangles. So if you recall, we have the words opposite, adjacent, and hypotenuse. And remember that the hypotenuse is always opposite from the 90-degree angle. The adjacent side is always on the other side of theta. So if you look at theta here, theta is always going to have hypotenuse on one side and adjacent on the other. And then O is opposite from theta, the furthest distance across the triangle from theta. Here are your trigonometric functions, but if you notice, the only ones that you learned in geometry were sine, cosine, and tangent, which are over here on the left. We also have three more that we use in precalculus called cosecant, secant, and cotangent. These are actually pretty easy to remember because they're just the reciprocal of the original three that you knew. So if you look at sine, for example, sine is opposite over hypotenuse, but cosecant is CSC, which is just hypotenuse over opposite. So they've just flipped the fraction. So I guess the thing that you probably have to absorb here are these three new names, how they're abbreviated, and which one they are the reciprocal of. So here you can write them in. You can say sine is opposite over hypotenuse. So cosecant is hypotenuse over opposite. Cosine is adjacent over hypotenuse. So secant is the reciprocal. And here you can say that tangent is opposite over adjacent. So cotangent is the reciprocal. Now down here at the bottom, one of the things that we like to talk about are the reciprocal functions. Tangent can actually be written as sine over cosine, and cotangent can be written as cosine over sine. And that's just a handy thing to know. You'll see it again. It'll pop up often in our course. So if we look at this particular triangle, we can form all six of the ratios. But first we have to label O, H, and A. And we have to do that from theta. Now H is easy. H is always across from the 90-degree angle. O is always, from theta. And A is always right next to theta, but it's not going to be the hypotenuse. So if sine is O over H, then cosecant is H over O. If cosine is A over H, then secant is H over A. Sorry, that's bad 6. And tangent would be O over A. So cotangent would be A over O. Now, if you didn't know one of these sides, say you had two sides and you were missing the third, you could use the Pythagorean theorem. Now, in this case, we have a little problem because we don't know all of the information that we need to know. We need to know what our O is, we need to know what our H is, and we need to know what our A is. And in this case, they only gave us O and H because they gave us sine. So I'm going to label theta. I always tend to put theta down here Really doesn't matter if you put theta in the other position. So my O and my H and my A are going to be there. So O is 1, H is 3, and I can figure out what my A is. I'm just going to clean this up a little bit. Sorry, folks. Still not better. So what I'm going to do is I'm going to use the Pythagorean theorem. I'm going to do a squared plus b squared equals c squared. And then I'll have x squared equals 8, and x equals the square root of 8. So that's my A. H is 3, O is 1. Now we can fill those in. Okay, pretty simple. Just going to get my pen back. Now in your calculator, you have to be in degrees to do this. So cosine of 35 times 7 gives me 5.7.